So in this class, we are going to discuss about the instruction sets available in our microcontroller. As we know, we are writing in instructions in the low-level assembly language, that is nothing but the mnemonics. So in a mnemonics, the basic structure is opcode and operand. So opcode is nothing but your instruction which has to be completed or which has to be compiled. And operands is nothing but the registers, memories or accumulators, wherever your data has to be stored. So this is nothing but your instruction. This is nothing but your data values or the storage space which you have to be operator. So for example, I am taking in an opcode language 4100 is address, which is to be where the instruction, your register and data values has to be stored. And move is nothing but your opcode A comma R, which stands for your accumulator comma register. So the instruction performs the operation move, that is data transfer operation, where the data value from the R1 will be transferred to the accumulator, that is moved to your accumulator, and the storage instruction will be stored in 4100. So this is the basic structure of your mnemonics. So first we are getting into the mnemonic language, that is low level assembly language. We have to know what are the opcodes available in our microcontroller. So totally we have 256 opcodes available in a microcontroller, whereas 255 we can write the opcodes, and one opcode will be used wherever the complex program is implemented. Okay, so starting from the instruction set, first one is data transfer instruction. So we know data transfer stands for to transfer data from one register to another. So let me know what will be the basic operation to transfer from one register to another. What are the operations you may see? Addition, subtraction. Addition. So data transfer is we have to transfer from one place to another. So we can take the operation like move x. Move stands for the basic transfer from one register to another or one register to accumulator, whatever. Pop. So push is nothing but we will be having a stack, right? In a memory, we will have a stack pointer. That stack is nothing but first term. So we have to use push and pop to store a data in the stack and to retrieve the data from the stack. So to push is nothing but put a data into the stack. Pop is nothing but take out the data from the stack. And we have swap and exchange. Swap is nothing but between the registers. So I have an 8-bit register. In an R register, I have 8-bit of values. I have to swap the lower bit and the higher bit. So I have to swap within the register. Whereas exchange is nothing but within the two registers. So swap is within one register and exchange is between the two registers. So these are the basic data transfer functions available for me. And coming to the arithmetic, so we know what are the arithmetic operations we are doing? Addition, subtraction, multiplication, division. So add, it stands for your addition. Addition with carry. SUPB stands for your subtraction with borrow. Multiplication, MUL. Division. And for subtraction and division, we will be using obviously the loop concept. So there we are using increment and decrement. So these are the basic arithmetic instructions. And next one coming for your logic. As we know, the basic logic is can be the OR gate, AND gate, or not, exclusive or exclusive not. So we have OR and exclusive OR, and the CPL stands for your change of your pointer. That is nothing but we are using a loop. So I have to change jump to the next loop. So instead of using my jump instruction, I can use CPL. And CLR stands for your clear option, and RL stands for rotate left, and this stands for rotate right. RLC, rotate the carry in your accumulator to the left. RRC, rotate the carry in your accumulator to the right. So I have to taking a diversion option. And that's all with my logical instruction. And another instruction I have a branching instructions. Yes, from jump, I have to jump from one loop to another. I can go with the jump option. Jump with carry. If it has a carry, I have to jump to the particular loop. Jump if no carry. Jump with carry if no carry. And I have to decrement and jump if it is not equal to 0. I have to decrement and jump if it is not equal to 0. And this is nothing but copy. Okay? Copy or else we can say it as if there comes an error value, if it is not equal or it may be an error value, I can copy the value and use it for the storing purpose. And next one is jump if 0, jump if not equal to 0, and this is the short jump. S stands for your short jump and this is your long jump. And accumulator jump, that is stands for your accumulator value, because accumulator is nothing but the operation and also used for a temporary storage. For example, I am adding the two operand values a plus b. The temporary c value will be stored in my accumulator. Once if I get a clock signal, the temporary value will be removed from the accumulator. So can you brush up me what are the instruction sets I have? The headings alone. Data transfer, arithmetic instructions, logical instructions, branching instructions. So in next time we can see with the help of these opcodes and operands, we will discuss the 8-bit addition operation in an 8051 microcontroller. Thank you. So good morning. In this session, we are going to discuss about a case study on our driver assistance system, and we can have an interactive session. Okay. So let us discuss what are the models available now and what are the cars companies have implemented the driver assistance system and what are the latest updates in that assistance system. So can I get a few points from your side?
Recently, we have seen that in Volkswagen, we can see it will see the driver's action. If driver he gets fatigue or he gets something dizziness or the automatically car detects it goes to the outside of the lane.
Okay, super.
Tesla introduced a driverless car driving system last month from manufacturing plant to buy a house without driver or any obstacles with highways. It automatically delivers to the buyer.
Yes, so we have assistant like if the driver is sleeping condition, it can identify it and it can help to get out of my lane, and it has a self-servicing also. So any other assisting systems? Can I get any point?
Apart from four-wheelers, heavy vehicles like lorries and heavy load carrying trucks are also companies are also implementing the systems like monitoring the driver's action and controlling the speed of the vehicle.
Okay.
So nowadays, it is implemented in cars, vehicle to everything, like V2X. It will note about the infrastructures of the cars and make the right decisions to what we want to do.
Yes. So can you tell me where this idea has moved from? Why the driver needs an assistance there?
Because of accidents.
Cause of accidents. Yes, we have a reason as a major cause, so that an idea has been arise to implement this. So is it the only thing the accident occurs due to an driver's carelessness? No, that's a failure from my internal system also. So what are the failures? Can you list down any of one item or any one failure from your system that causes accidents?
Braking.
Braking, very good. So that comes my anti-braking system or auto-lock braking system. You can have various terms in that. So can you tell me any one car or any company which uses this ABS? Mahindra, very good. So what is the operation of it? Can you brief it?
Automatically responds for rainy days when non-ABS vehicle will skip, ABS vehicle will not skip.
So have you any of idea like how it is measured and how it operating principle is done in ABS? So we know driver assistance is nothing but assist to the driver, but not only the identification of drowsiness or identification of alcohol drink, not only that. Apart from that, we have another assistance systems like ABS, and this ABS is not only have implemented only in braking system, also in automatic parking in same Tesla. Automatic parking. This is also assistant to one driver, right? There are no need of risk to see the parking lot, or I don't have to risk of taking in any of miscarriage. So there comes my automatic parking system. So what is the main idea behind the parking system? What are the components it may include?
In India, recently, Tata had implemented this idea in Tata Harrier. The model is called Tata Harrier. They implement like a keyless model. It will control through a remote. If you once you park the car, if the car is many cars surrounded, you can't go inside the car door. You can use that key and press the button, and automatically car come out.
Yes. So you have seen in movies, I have one smart key. I just go out of my gate, I just press the key, the car takes out of the lane and comes automatically out to near to the gate. So it automatically pick my customers or passengers. So it is also well trained, right? So that comes my pure programming side also. So we know as a driver assistants, we are going for the only that identification and helping of that parking, that's about. But apart from that, for the full automator side, we have to focus on my programming also. If one system in my programming fails, or one component in my electronic system fails, or in any of my chases design fails, everything will be collapsed. So driver assistance system is not only one part, it is divided into subparts. I have to focus on my chassis design, my body part designing should be focused, electronic components should be focused, my engine has to be taken care, and my other applications like embedding system that has to be taken care. And nowadays we have lot of vacancies in the car companies for an embedded engineer. Can you get any point regarding that? Have you gone through any job vacancies for an embedded engineer in a car company?
There is a Bosch company. They are recruiting people for embedded systems. They are producing the products for automobile industry. So Bosch is the one of the biggest sector in supplying the parts of the parts to the automobile industry.
Very good. And I have a company like Next's Solution. So they are tier 2 companies to the next to the Bosch. So they are working on the automatic steering system. So here every part has to be manufactured individually and it has to be interfaced very carefully. So they are working on the automatic steering and they need a help of an embedded engineer. Why? Because a driver should not sit in a seat and driver is not going to handle that steer, but the steer has to be rotated right and left depending upon the speed and depending upon the instruction from the engine or from the chassis design, and everything has to be interfaced. So that a mechanical engineer alone is not required, it's not enough. And whereas a programming engineer alone is not enough. There should be an electronics engineer where they have to tell whether the sensing of the speed is accurate or not. If the sensing of speed is not accurate, it then collapses the whole system. So we have more vacancies in that also, not only in JSS design and not only in pure IT. An embedded engineer has also in vacancies in these types of sectors. So I think you can go through a lot of companies in automobile itself where the automatic and unmanned vehicles have been designed. You can find a lot of job vacancies which are really unknown for us. So have a glance of it, and if any case you can have an help with me, you can contact.